Welcome to Jackal DIY and Tech. In today's video, we'll hook up this electric strike lock, which at the moment is locked, to an Arduino and open it automatically with this code every 2 seconds. So 2 seconds on, 2 seconds off, and this will repeat. So if we just take a look at the code, what we'll be using, we have the pin 2, which will be the light on the node MCU. Now I think the signals are switched when it comes to the light and the actual signal to the lock. In the setup mode, we initialize the 2 pins. So the signal pin will be D1. We have some serial communication, so we can see the output in the serial monitor inside the Arduino IDE. And if you want to know how to set this up, I suggest you watch the basics Arduino video that I have, and if I don't forget, I will also put it up in the correct description and maybe also in the description down below. So we'll be using this baud rate to see the communication that is printing out, and we'll set the initial pin relay value to low. And then in the loop, the LED state, which is on the node MCU, this starts as false, and then we switch every time the loop ends. This digital right, this is for the pins, so the LED pin, what will its LED state be? It will be high or low depending, well, on the LED state. And the same for the pin relay. It also looks at the LED state, so maybe I'll just switch this from low to high, from high to low and from low to high. So we have the same type of behavior as one would expect. So how will this light up? And how will this be connected? Well, firstly, let me just connect this. And what this is, it is a relay. So this is a relay. So this is a basic relay for Arduino type logic. You have the positive, which is 5 volts, you have the ground, the middle pin, and on the right you have the signal pin, so you can enable the relay when you want. And on the right side you have the plus, which is the voltage that you want to use. In this case we'll use 12 volts to power this electric lock. This is the middle pin, but this relay can also go up to 250 volts AC, but for now we'll just use 12 volts DC. And as for the DC voltage, it can go up to 30 volt DC. So the positive will be the middle pin, which is COM, and the normally opened, which is NO on the left side, this will then go to the positive on the device that you want to power. So in this case, it's connected to the right side of this electric strike lock. So the right side is plus, positive, the left side is negative, and this negative will go directly to the negative of the power supply. It's this black alligator clip, and the red one is the positive. So for now, I will just connect it as one would expect. Now the node MCU has this type of pins, as does the relay, but I don't have wires that would have this type of connector on both sides. They have also pins on one side, so that is why I have to use this proto board. So I connect all of the pins like so, connect one side of these pins in the proto board and continue the connection from the proto board to the relay using the other side of this connector. Now how this is set up, so the black wire is the ground, the signal pin is white, it's on D1 because that is what I have set up in the Arduino IDE, and the gray wire is connected to VU, which is 5 volts on this node MCU, version 3 board. So I will simply put the connectors in the same way that the relay has. So the VCC is on the left side, this will be gray. Then we have the ground, this will be black. And lastly we have the signal pin, which is white. So that is the connection. And now I'll do the same thing with the relay. So we have the VCC, which is the voltage. In this case, this is now magenta. So the voltage is gray. The ground is blue. And the signal is green and connects to the white one, which is correct. Now the only thing that I need is connect this wire to the ground on the clamp. Make sure that this is actually in and screwed in place. So that should be tight enough. So this one from the relay will go to the positive of the 12 volt on the clamp. So this one is going to the plus on that side, and this one has to go to the ground. Nothing is happening yet because the Arduino is still not powered on. So I will now hook up this cable, which is connected to my PC, and it provides 5 volts and also communication to the Arduino IDE. So as you can see, the LED is flashing off and on every 2 seconds. But we have an issue, and that is this electric strike clock constantly has power. Now where could be the issue? Well, apparently the issue is with this unit. And that's because, well, somehow they, I don't know, chipped off. It's missing something. And that something is actually, and well, firstly, let me get a multimeter so we actually see what the issue is. Now, because I'm using up to 12 volts, I just set the voltage to 20 volts, but I don't need it to be this high. So what the issue is, in this case, is the voltage, or at least the current that is running to this relay unit. As you can see, the red LED is indicating the power to the unit, which is 5 volts, and the green LED is the trigger signal, which in this case is the green wire. This one should not always be on, in this case it is. So we have to take a look at the signal, which in this case is pin D1. So I will connect the black probe to a ground, doesn't matter which one, and red one to D1 signal and look at the voltage. As you can see, the voltage is jumping from 0.11 to 3.34 volts. So one is the logical 0 and one is the logical 1. And in this case, as you can see, because I have not updated the sketch to the board, the values are actually different. So it should be 3 volts when the LED on the node MCU is on and 0.11 volts when it's off. But what this means is that the voltage is actually not 0. It's 0.11, which is too much, and that is why the electric strike clock is always on. So to fix that, we have to use the transistor like this one. Now it's tiny and you won't be able to see it, but it is. So I actually used the wrong one, but it still works. This one is S8050. The one that I wanted to use was actually 2N3904. I messed up the mercs, so I used this one S8050. No, it still worked, but I guess I just needed a higher value resistor for it to actually work, so we'll do a quick test. So I have quickly done some tests on which transistors work with this setup that I have. Now the 2N3904, this one does not work. This one, 2N3906, this one does, as does the C1815, S8550, and let's see which one was. This one S8050, the BC337, this one did not work, but the BC327 did. And also, did I test this one? 2N222A. Let me quickly test this one, because it is also very common. Oh, actually, I made the mistake again. This is not 2N222A. This was the MPS2907. Let's see if this one, which is one of the most common ones, work. Hopefully it does. If it does not, well, nope. The 2N22222A does not work. So I'll take the BC327, or actually the 2N3906. I think this one should also be common, but if you get a kit with a bunch of transistors, you should be covered. Now about the wiring. So we have the signal pin coming from Arduino. This is connected to a resistor. In this case, this is a 20,000 one. Maybe you will have to change the value depending on the load that you use. But in this case, a 20,000 ohm resistor worked just fine. So this will be wired in series, and the leg of the resistor will be connected to the base of the transistor, which is the middle pin. So the base, the middle pin, will be connected to the resistor. Then one leg will be connected to the ground. This is connected to the ground of the power supply, which is, in this case, is 12 volts. And the other will be connected. So let's see, the other is connected to the signal on the relay. So basically what we do with this is have 0 volt, which is the ground, or either the full value of the signal, which we don't have if we just connect the signal pin directly to the relay. As I have showed you, we previously had either 0.11 volts or 3.34 volts. So the middle pin of the transistor connects to the resistor. One leg, this will be the signal pin, will either go to the collector, and the other will go to the emitter. Now it would work if I actually took the right transistor. This was 337. I meant to take 327, or actually the 3906, which is this one. So even though I have everything written down, I still make the mistake of which transistor I actually want to use. So the electric clock is now working as intended. Almost anyway, I still didn't update the sketch. Now hopefully you can see that the green LED is always on, but when it is off, it's a little bit dimmer than when it is on. And I guess I have updated the sketch. Because the lock is unlocked when the LED, the blue one, on the node MCU shines. Now obviously you wouldn't want the electric lock to just unlock automatically once every 2 seconds. So what you could do, instead of just using the electric lock and a simple button, is use something maybe like a fingerprint reader. I still have to test this out, how it actually works and how you set it up. But this is one solution that you can use. The second solution that you could also use is something like this. What is this? Well, it's an ultrasound device that detects a distance. In this case, you could unlock the door once something gets close. And then instead of a button, you could use something like this. This is a Hall effect sensor. It works using magnets. So in a sense, it's the same as using a button, but this activates using magnets and you don't actually press anything. The magnet just has to come close enough for it to activate. Now this Hall effect sensor is on the cheap side, so it is only off or on. It doesn't actually detect how far the magnet is. But if you need a simple solution, this can also be a way how you can activate and unlock an electric lock using the Arduino. I think that covers everything when it comes to an electric strike lock and using Arduino and how to power it on. So if you found the video helpful and would like to see more content like this, subscribe to the channel and we'll do something else in the next one.